2, 1, go. Okay, so in this video we're going to talk about functions. Now, a function is basically a relationship between what we call a domain and a range. So I need to define what a domain and range is for you. Okay, so the domain of a function is basically the set of all inputs, and the range is the set of all outputs. So for example, if I give you a list of ordered pairs, say 1, 3, 3, 4, 5, 7, -1, -4, -5, 7, and 0, 0. Okay, so here's a list of ordered pairs where the first component, those are your inputs, and the second component, those are your outputs. So if I ask you to find the domain and range, I'm just asking you to collect all the input values for the domain. So that will be 1, 3, 5, -1, -5, and 0. And for the range, we'll just go ahead and collect all of the output values. Okay, and those are 3, 4, 7, -4, 7, and 0. Okay, now pictorially we can think about domain and range as this. Let's say I have 2 ellipses. This one will represent the domain, and this one will represent the range. And let's say I have elements in my domain. Now we're talking about elements that maybe aren't numbers. Okay, and let's say we have 2 elements in the range there. And if I draw a relationship between the elements of the domain and the elements of the range, for this to be called a function, each element in the domain can only correspond to a single unique element in the range. Okay, so for example, if I draw something like this, this is a function, because notice each element in my domain here only has one, let me make these arrows, only has one arrow coming out of it. So there's a unique element in the range that this element maps to, a unique element in the range over here that this element goes to, and so on. But now if I gave you something like this, now we have a problem here, and this is no longer a function because you can see here this element in the domain goes to 2 different elements in the range. But we can have multiple elements in the domain going to a single element in the range, like this. Right? So just because this output here corresponds to many inputs, the important part to note, if I want to call this a function, is that each element in the domain has a unique output. Each input here has a unique output. Okay, so when we talk about functions, we use what's called function notation, which looks like this. F of x. Okay? One thing you need to know is this is not multiplication. Don't get that confused. Whenever we talk about multiplication, we'll write f times x or f times x like this with parentheses. But whenever you see this, we're talking about a function. Okay, now remember, when we're talking about functions, we talk about inputs and outputs. So here's a list of different ways to talk about the input and output, different words. Okay? Independent variable, horizontal axis. If you have a coordinate pair here, your input is always the first coordinate. If you have function notation, your input is what is inside of the parentheses. And then, of course, if you talk about the domain of a function, we're talking about the entire set of input values. Okay, and then your output, dependent variable, vertical axis. If you have a coordinate pair, your output is your second coordinate. And if you have f of x represents the output value at whatever input x is. And then your range is your set of all output values. So let's take a look at some examples of evaluating functions. So the first one here, let's say I give you that the input is equal to 3, and I give you a function, g of x equals, let's do g of n equals 4n minus 1. Okay, and let's say we're asked to evaluate this function with input equal to 3. So notice in this function, our input is n. Okay, so we're going to take parentheses around n in our function. So replace your input with parentheses, is what I meant to say. And anywhere you see parentheses now, you're just going to input the value 3. Okay, so then when we simplify, this is 12 minus 1, which is 11. G of 3 equals 11. Let's take a look at another example. So let's say we have the output equals 2, and I give you the function f of x equals 3x plus 2. So now, in the first example, we were given the input, but now we're given the output. And remember, in this list, we said the output was your f of x. So looking here, my output, I put parentheses where f of x is. And I'll replace my output with 2. And now we're going to solve for x. So we have 2 equals 3x plus 2. So to isolate x, we'll go ahead and subtract 2 from both sides. That's going to give us 0 equals 3x. And then divide both sides by 3. 0 divided by 3 is 0. If I divide 3x by 3, I get x equals 0. So I've solved for the input when I was given the output. Okay, so in example 1, we evaluated our function g at input equals to 3, and we got 11. And in example 2 here, we solved for our input value when f of x gives us an output value of 2. Okay, let's take a look at 2 more examples. So let's say we have an ordered pair where we're given the output 1/2, and we're given a function w or omega of theta equals theta plus 1 divided by 2. So since we're given the output here, we're going to solve for the input theta that gives us w of theta equal to 1/2. So our output is w of theta, and we're told it's 1/2, so we'll put parentheses around where w of theta is and fill in the rest. And now we're just going to replace w of theta with the output that's given to us, 1/2. And then we'll solve for theta. So we'll multiply both sides here by 2. 1/2 times 2 is 1. If I multiply this whole side by 2, I just get theta plus 1. If I subtract 1 from both sides, on the left side I get 0. On the right side I get theta. So theta equals 0. That is our input value for output equal to 1/2. And then let's do one more example. I'll go ahead and move over here. We have an ordered pair where the input is -1, and we're given a function h of k equals k to the 100th power plus 1 all squared. And now we're given this input value of -1, so we're trying to evaluate this function at k equals -1 to determine the output. So wherever I see a k, I'll replace it with parentheses. And now I can just plug in -1 for k, or where I have the parentheses there. And now we simplify. -1 to the 100th power, -1 to any even power is going to give you +1. 1 plus 1 is 2, and we're squaring that, so we get 4. So when we evaluate h of k at k equals -1, we get an output of 4.